afternoon. Welcome back to the new chapter. Actually, we can have some more problems in the equilibrium and all, but okay. If anybody wants, we continue. Otherwise, we will go to the hydrogen and its compounds. This is one of the smallest chapter and the simplest, easy this thing. If you see the abundant wise, hydrogen is the third most abundant element in the universe. Okay, in the earth, because it is say any element when we are talking, first we will say where it is located in the periodic table, whether it is elemental form or it is a molecule form or how it is occurrence, then how it is isotopes and all, preparation, physical properties, chemical properties and compounds and all. That is normally for any element, that will be the general trend what we follow this thing. Now let us go to the hydrogen form. Hydrogen in the universe is available as a molecule form, elemental form, that is H2 is available. And it is the third most abundant element in the universe. It is in the water, it is has H2O, most of the time in the earth. But if you see the stellar this thing, most of the reactions are the bigger planets of like Jupiter and Saturn is nothing but contains only hydrogen. In the earth it is a lighter element, so at crust it is a very limited as a gas. Fine. Now first of all, where it is located in the periodic table. It is a very funny, or the most discussions are still going on where to keep the hydrogen. Hydrogen is the simplest element and it is having only one electron and one proton in the hydrogen. So because it is having one s, so people say it should be the first group, that is in the alkali metal group, because it is only one electron. Means in the outermost shell it is only one electron. See, other way the people will say it should be the 17th group, the halogen group, because it is one shot. So people will say it is belongs to halogen. People say it is a alkali. Actually, if you see some properties, it belongs to the alkali metal type side, and some other say it is in the properties of this thing. So it is not completely in any one of this one. So it is having its own identity. So it will be kept as a separate in the periodic table as 1s, neither in the first group or not in the 17th group. That is in the periodic table. So some properties it is matching with the halogens, some properties it is matching with the alkali metals. Fine. Hydrogen having as I told you, the occurrence, it is in the universe, so third most element. Now hydrogen having three isotopes, means hydrogen, deuterium and tritium. What is the difference in the isotope? Everybody knows that the mass number will be different and the atomic number will be the same. So in the hydrogen, one electron, one proton. In the deuterium, the second isotope of the hydrogen. One proton, one neutron and one electron. Another one is the tritium. Tritium is one proton, two neutrons, one electron. That is atomic number 1, mass number 3. Deuterium is atomic number 1, mass number 2. And in this 3, hydrogen is, everybody knows hydrogen is a good fuel, and hydrogen not only occurring in the hydrogen gas and this thing. Hydrogen is a very good what you call available as a carbohydrates, that itself is a separate entity, and crores of elements, molecules are available, or the compounds are available. Fine. Whereas H2O is not what we call is water or light water. In the nuclear applications, yes, there is one more water is called the heavy water or deuterium water, D2O. That is the heavy water. And this heavy deuterium and the hydrogen are non-radioactive, whereas tritium is a radioactive element and which is a beta emitter. Tritium is a beta emitter. So the third isotope of the hydrogen is a nuclear radioactive element, whereas hydrogen and deuterium is normal these things. This is about the physical and the appearances and all. So normally the hydrogen will be the prepared, how it will be prepared, preparations will be the laboratory, any metal with, if you are adding with any general acid, that means easiest, simplest normal laboratory method is the zinc plus hydrochloric acid is called zinc ions, zinc plus hydrogen gas, that is the zinc chloride plus hydrogen gas. Similarly, zinc plus sulfuric acid, if you are adding zinc sulfate and hydrogen gas, and that is the laboratory methods and all. That is an acidic media laboratory experiments. In the laboratory itself, the alkali media also is there, that is nothing but zinc and sodium hydroxide. You will get a hydrogen gas and zinc sodium hydroxide compounds will be there, but hydrogen gas can be prepared in the laboratory in the form of with the base also, alkali also. That is the, but they are not economically viable. Means this is not the industrial methods, this is the laboratory methods. Whereas in the industrial methods, the most common method is the electrolysis of water. Electrolysis of water is the most common for the economical production of the hydrogen gas. Hydrogen gas is also called the clean gas, because when it is burnt, it will be as a water only producing, so there is no carbon production, so hydrogen is called the clean gas also. It is a lighter, so most of the time people want to make it as a liquefied hydrogen, then it will be, if you are able to make it a solid, very good, but it is very difficult, because hydrogen is normally boiling point itself is 13K like that. So the commercial this thing electrolysis of water, and or otherwise the brine solution electrolysis also people will be using for the production of the hydrogen gas, or it can be prepared by the stream of hydrocarbons. Stream is passed through the hydrocarbons, particularly alkanes. Alkanes general formula will be CnH2n plus 2 pass through the stream, that is H2O. You will get a CO and hydrogen gas. So example, if you take methane plus the steam, you will get a carbon monoxide and hydrogen gas. Interestingly, carbon monoxide and hydrogen called as a water gas, and in some countries it will be called as a syngas also. This is called synthetic gas. Syngas or water gas, both are same, that is the and it will be prepared, even carbon and the steam can also prepared as a carbon monoxide and hydrogen gas. That will be the whereas the carbon monoxide and again water, if you are getting the carbon dioxide and water hydrogen gas also will be formed. Now, where physical properties, if you see hydrogen gas, hydrogen is a gas, and it is a colorless gas, and it is a odorless gas, and is highly combustible gas, having high energy gas. It is lighter than air and insoluble in water. It doesn't soluble in the water. So that is the normal, what we see is it is lighter than water, lighter than air, and insoluble in water, odorless, colorless, and high energetic gas. That is the physical properties. Normally chemical properties, when you go this thing, chemical properties normally will start with the formation of chlorides, formation of metals, metal reaction with the metals, like this and all. So tomorrow we will see the other properties and other things. So thank you.